Today I'd like to share with you how I learned about the Phoenix LiveView internals by trying to build it from scratch, well, at least one part of it. But first, my name is Ignacio. I'm a software engineer at WiWorks, and WiWorks is a software consultancy agency building software in Elixir, Ruby on Rails, and JavaScript. And the reason I'm doing this is because I will find it easier to learn by doing. So when I was trying to understand how the Phoenix LiveView works, I thought it might be a good idea to try to implement it myself. But of course, LiveView is huge, so I didn't actually expect to implement the whole thing, but to focus on one of its components. But which one? Well, let's try to pick one. So this is an overview of how LiveView works, and I'm assuming most of you are familiar with this, so I'm going to go through it really quickly. So it will start with a regular HTTP request, then mount and render are called from the LiveView, and then a server-side render HTML is sent back to the browser. But after that, the browser opens a socket connection to the server, mount and render are called again, but now instead of sending back an HTML, it sends back a structure telling the browser which part of the page are dynamic and which one are static. And once the user starts to interact with the application, it only sends back the thing that changed. So I think we can split this into 3 different modules or components. So we have one that happens in the client, and it deals with opening the socket connection, patching the DOM, and since this is all JavaScript, maybe this is a topic for another conference, so we are not going to get there. Then we have another part that is with the render, and it's in charge of tracking the thing that changed, splitting the HTML into the parts that are dynamic and static. And I didn't find it too amusing, so we are not going to get there either. So what's left for us? Well, there is a section in the middle that manages the messages being sent through the socket. And this is the part we are going to replace. To do that, we're going to use the thermostat example that I think most of us already know. We're going to try to reverse engineer the Phoenix LiveView channel so this application keeps working. So if you've never seen the thermostat, don't worry, we'll play with it in a second. So what are we going to do? So we are going to create a new channel from scratch. Then we are going to put some hardcoded data into it, so we can check the browser is able to render the thing we put in the channel. And then, after a series of incremental steps, we are going to replace that hardcoded part with actual data. So let's get into it. So this is the thermostat application. I'm going to reload the page. And we can see it starts with a, I hope you can see it. Let me open this. Okay, it starts with a regular HTTP request, and it returns a server-side render HTML5. But after that, the browser opens a socket connection to the server, and we can see we have the first message here that tells the channel we want to join. And after that, mount and render are called again, and it sends back this structure containing the part of the pages that are static, that never change, and the dynamic part. So what the browser is going to do is going to take one element from this list and one element from the dynamic, and it's going to merge it together. And we can see let me try to zoom this in. Okay, I cannot do it. Okay. We can see the messages from LiveView are prefixed with LB, so I'm going to filter this so we don't get too much noise. Okay, and what happens when we start to interact with the application? Okay, we send a message telling which event we did, and what we get as a response is only the thing that changed. We can see we have the key here, that is 2, because if we go back to the first response, we have the dynamic values identified with a key. So now the browser knows it needs to update that value with a key, with a new one. So if I change its mode, okay, it says we toggle the mode, and we what we get back is the heating and heating. And the reason we have two is because one is for the class that makes this red or blue, and the other one is for the label. So great. If we were to build something like Phoenix LiveView, we need to find a way to deal with sockets, and we need to handle events being sent by the browser and return render updates. So, lucky for us, Phoenix already provides support to work with socket. So let's try to create a channel and a socket. And to that, I'm going to use some generators. Can you see the text there? OK. So I'm going to use the channel generator to create a new one, call it Big Elixir. And it says if I want to create a default socket handler, but I'm going to say no because I don't like its default name. So I'm going to use another generator to create the socket, and I'm going to call it Big Elixir 2. So fine, now we need to do the rewiring. So we need to tell Phoenix to use this channel instead of the LiveView one. So let me change this to white first. OK. So let's open the app.js file. Here we have the socket configuration for the client side. And we can see it's trying to open a connection at the live endpoint. So let's go to the endpoint file. And here we have the live endpoint, and it's pointing to the LiveView socket. So let's replace it with our custom one. So this is my app web, Big Elixir socket. So now let's go to the socket. OK, and let's follow the instruction here. So it says we need to uncomment this line to define a topic pointing to a channel. So I'm going to uncomment this, and I'm going to change this. Remember, the messages are prefixed with LV. So I'm going to change this. And we're going to point it to the Big Elixir channel. And great, so now let's go to the channel. Sorry. Channel. And here we have the join callback, where we have the logic where someone connects to a topic, and the handling callback, where we process the messages being pushed to us. So let's get rid of the thing we don't need, and we also need to replace the matching in the function. So this join is going to be the LV plus something. So I'm going to replace this. Sorry. Plus something, we don't care. And I don't care about authorization, so let's get rid of this. And also, I'm going to handle every event here. So let me get rid of this. And we're going to match every event here. So we don't need this. We don't need this anymore. So let's remove it too. OK, and to check this is working, let's print some output here. So let me do this. So I'm gonna print some result here, handle in. And OK, let's restart the server and see what happens. So now, if we go back to the application, I mean, of course, it won't work because we are not returning anything useful. But if we go back to the terminal, we can see we are handling the events with our socket. So this is pretty great. So we have the join here, and whenever I click here, okay, I have the handling. So let's try to send something the browser can deal with. So to do that, we're going to put some hardcoded data here. And we're going to use the same thing we saw when we were playing with the thermostat at the beginning. So let's do this. This is the same structure we had in the demo before. So to check this is working, I'm going to change the temperature here. I'm going to put 60. So now, if I reload this, okay, we can see. Let me try to do it again. Okay, we can see it's updating the page with the thing we have here. So we know how to return something the browser can update. So let's try to do the same in the handle-in. So let's do this. I'm gonna just to return the thing that changed. We don't need a static part anymore. Let me replace this with heading. So let's reload this again. And now if I interact with the application, it's updating with the thing we return here in the handle-in. And of course, the interaction with it is pretty limited because we are always returning, we are always returning the same no matter what we do. So let's try to send actual data to the browser. How do we do that? Well, we know the data it's updated in the thermostat LiveView. So let's open that file. Let me swipe the panels. Okay. So here we have the mount function that it receives a socket, and it sets in its assign the initial values. And then we have the handle event function that, based on the type of event, also updates the socket accordingly with the values that change. So let's try to call those functions on our channel and see what it returns. So let's do this. This is my app web, thermostat, live, mount, and it gets 3 parameters. The first one, we don't care about them, so I'm going to send nil. And the other one is a socket. So let's try to print this out. Mount. Okay. Let's see what happens if we do this. Okay, this is breaking. And why is that? Well, let's see what the error says. Sorry, never mind. Okay, it says it's an argument error in the assign function. So it's in this function in the assign. It says it expects a socket as a first argument, but it got a Phoenix socket. So it expects a socket, but we are actually sending it a socket. So why is that? Well, this is because this function receives a LiveView socket, but our channel receives a Phoenix socket. So it's something like this. This is track Phoenix socket. So it's the same we return here, but this is expecting a Phoenix LiveView socket. And why is that? Well, this is because LiveView needs to store more information in the socket, and in particular, it needs to keep track of the things that change. So you need a place where to store it. So to fix that, what I did is, I didn't know what this error, what was the cause of this error. So I had to take a look at the actual code. I just copied the function that transformed one socket into the other, and it's really simple. Let's just create that function here. And what it does, it takes a Phoenix socket, and it returns a LiveView socket. And I'm just getting the things I need from the socket. I'm going to create a new LiveView socket. But the important thing here is that we need to add a new key in the assign, where LiveView is going to track the things that change. So let's update this assign. So I'm going to do this map put assign, and the new key is called change. So change, and it's an empty map. So let's put here an empty map. So now the LiveView socket, besides the assign of the Phoenix socket, it contains a new key called change. So let's try to call this function. Let's try to transform the socket. So let's do this. LiveView socket is transform socket, and this is the Phoenix socket. And now let's call this function with the LiveView socket. Let's restart the server. And I'm gonna reload this. Okay, here we have what it returns is a Phoenix LiveView socket. It contains in its assign the new key with the change, and it says that the mode value and the val value were updated because this is initial call. So since they were initialized, they were updated. And we also have the actual values. We have that mode is cooling and the temperature is 72. So let's try to bind those variables and replace it in the hardware data here. So this returns OK and a new LiveView socket. And let's bind the assigns here. So let's do this. Mode is mode, val is val. And this came from the LiveView socket assigned. So now we can do this. Replace it here. This is the mode. This is the mode again. And this is the val. And one last thing here is that here we need to return a Phoenix socket, but the assigns were updated in the LiveView socket. So to keep it simple, I'm just gonna replace the assigns in the socket with the one from the LiveView and return the Phoenix socket. So I'm gonna do this updated. Socket is map, put the Phoenix socket, and I'm gonna replace it assigns with the LiveView socket assigned. So we can keep the state in the socket. And let's return the updated socket here. And let's do this in the handling very quickly. So this is no reply, no reply, no reply, and a LiveView socket. So this is handle event, my app web, thermostat live, handle event. We have the event in the payload, so let's use it. Payload, we have the event here. We don't care about the second parameter. And then a LiveView socket, I need to transform the socket here too. So let's do this. LiveView socket is transform socket with a Phoenix socket. Let's replace the hardware data too. So I'm gonna paste it here. And I also need to return the updated socket. So let's hope this is working. So I need to do the binding. Great. So let's try to reload this. And great, now we are able to change the state of our application. But we still have issues, right? Because we are relying on this LiveView to have exactly those two values and name exactly like that. So what happens if we need to add a new one or if we need to rename them? So here is where the render function comes in handy. So the render function receives an assign, and let's see what it returns. So let me do this. This return, I don't know, but let's do this. My app web, thermostat live, render, it gets an assign. I'm gonna print the result here. Let me get rid of this spec here. Okay, let's try to see what we got here. So reload this. And okay, it returns this structure that contains, among other things, a dynamic key and a static key. In the key, we have the pieces of HTML that never change, and it's the one that we have here, so we can replace it with the one from the render. And we also have this dynamic value here, that is a function that returns a list with every values in the assign. but not every value in the assign, but in the order, sorry, in the order they appear in the template. So we have a list here with cooling, and 72, because those are the way they appear there in the template. So what we're gonna do is to get those, bind those values here. So I'm gonna take the dynamic, and the static. Let's get rid of inspect. And let's try to call this function, the dynamic function. And the reason this is a function is because we can tell that function if we like to keep track of changes or not. So let's say we don't care about it, and we'll see what it does later. If we say we do want to keep track of changes, but for now we don't care. So let's call this function dynamic, false, and let's print the output here. Label values. Okay. Okay, it says static is not being used, but let's not worry about it for now. So let me reload this. What's going on here? Okay. Oh, this is LiveView socket. Okay, let's see if this is working now. Okay, it's working. Here we have in values this list with cooling, and the temperature. So I'm just gonna take the value from that list, and using enum add is gonna be fine for now. So let's replace this. Enum add values 0. Enum add values 1, and enum add values 2. And we can replace the static list here. So I'm gonna use the one from the render. And I don't need this binding anymore, so let's get rid of this. Sorry, this is enum, but okay. Let's try to do the same in the handling. So I'm gonna call the render here. We don't need the static part here, so let's remove it. We don't need the binding either. And let's take this and put it here. We need to call the dynamic function here. So let's see if this is working. This should keep working. So let's reload this. And okay, this is working. But we still have issues because we can only have three variables here. So we need to find a way to create this map dynamically. And it shouldn't be hard, because if you take a look at it, it has an index as a key, and then the value from that list at that position. So let me open an Elixir console here, and let's try to transform that list into this map. So we have something like this that contains cooling, and 72. So we need to add an index to it, so let's just use enum with index. This is with index. Is enum with index. This takes the list, and a function that receives the element, and the index. And let's just return a tuple containing the index and the element. So now we have this type of list. And let's use enum into to transform that into a map. So if you use enum into with index and an empty map, we have pretty much what we need, right? So we only need to add a static part into it. So let's add a function that does exactly the same which I did here. So I'm gonna go, let's go here. This is sensitive, okay. And this takes the list and does enum with index and enum into. And then I have another little function that just puts the static part into that. So let's replace this render with a call to a function we just created. So render is will diff struct the values, and let's add the static part, and let's get rid of this, and let's do the same in the diff here. Will diff struct with the values. Okay, let's see if this should be working. Okay, but we still have one minor issue it would be great to fix. That is, we are returning all the values here, no matter what we change. I mean, the values are correct, but we don't need all of them. So remember that this function here, the dynamic, receives a Boolean. So here we can tell that function if we like every value or just the one that changed. So in the handling, let's replace this with true. And let's try to see what it returns. I'm gonna close this. Okay, let's try to reload this. And if I change this, okay, this is breaking, but the reason is because now we have the same list, but it contains nil in the position where the values haven't changed. So if I click on the mode here, okay, we have null here, but the mode is correct because we have this. So we can filter the nil values out, right? So let's do this. I'm gonna recheck those values here. Checked. And this gets a list from the pipe, and then a function with the element of the list that is in the form of index. We don't need it. The element, and if it's nil, we are going to reject it. So let's see what happened now. Okay, this is working, and if we go here, okay, we only have the things that change. So I'm gonna change the temperature here, and yeah, we only have this. So this is great. This is pretty much done. Except that we are only allowed to have one live view called thermostat live. So to finish this, we need to find a way to know which live view is connected to the socket. And I didn't know how to do this because it's not in the socket. So I had to go to the live view call and see how they do it. We do have a way to know the module we need to call here because it's in the session information in the payload. And I don't want to get into the details here, but let me paste the function that takes the session information and gets a view. So what this does is take some token from the payload. It calls this verify session, and it returns something that is a session struct that contains the thing I need, that is the view. So I'm returning the view here, and let's try to print it and see if that's the one that we need. So I'm gonna do this. Get view. It receives a socket and a payload. And let's print this. Label. Okay, view. And I'm gonna get rid of this. Okay, let's reload this one second. And here in the view, where is it? Okay, there it is. So now we can replace the module with this value. But there is an issue here, that is that we only have that information in the join, so we are not able to use it in the handling. And what the real LiveView does is they implement this whole channel using a change server, and they keep a state. But for simplicity, let's not do that. Let's take the same approach I did to keep track of changes, that is to put in the assign a special key with the view. So let's do that. Instead of getView, I'm going to rename this to setView. So we have the view here. So let's put that view into the socket assign. So let's do this. New assign is map put into the assigns. A new key that I'm going to call it view. And this is the view we have from the session. And let's return the socket. So I'm going to put in the socket the new assigns. So let's replace this with a new assign. And now we can call it from here. So let's do this. We need a LiveView socket. And this is going to be socket. Let's set the view in that socket. And it receives the socket and the payload. And then let's transform it into the LiveView socket. Transform socket. So let me remove this. And now, And now we can get the view from the socket itself. So let's do this. Let's match the view. Let's find it to a new variable that I'm going to call it view. And let's take it from the socket assign. And now I can replace this with a view. So view here, view here. Let's do the same in the handling. So I'm going to take the view from the signs, and I'm going to replace this here. And let's hope this is working. So, okay, it seems to be working, but just to be extra sure, let's create another view. So, to keep it simple, I'm just going to copy the same view, the thermostat LiveView to thermostat LiveView 2. Let's try to open that new view here, thermostat LiveView 2. Okay, let's rename the module here. And let's tweak it a little bit so we know it works with every type of value or template. So I'm going to remove the toggle mode functionality. So let's remove also in the initialization. And let's remove the handle event for the toggle mode here. And also I don't like the val because it does the val name because it doesn't make sense to me. So I'm going to replace it with temp. So let's replace the val with temp. Now let's go to the router and let's create a new one. This is thermostat 2. This is thermostat 2. Okay, let's see. Okay, this is working. So we can have several views with different type of values. Yeah, this is pretty much it. So to sum up, so what we did is to replace the Phoenix LiveView socket and the channel with our custom one. Then we return hardcoded data in the join and handling function to check that the thing we return is being the browser can manage it. After that, we replace the hardcoded values with the one from the mount and handle events. We created the diff structure dynamically, and finally, we added the possibility to have multiple LiveViews. But what's the point, right? Well, for me, this is a great opportunity to learn about how something works. And even though this is an naive implementation and it won't work in real life, it allows us to ask questions and think about how they might be implemented. For example, this only works with browser events, but what if we need to add support for server events in case we like to add a timer here, for example? Or how does Phoenix LiveView manage to split the HTML template into the dynamic and static parts? And for sure, we won't reach the same solution the Phoenix LiveView contributor did, but we'll grow from a technical perspective and we'll gain a lot of knowledge. So, in this case, we learn about how sockets are being used to handle events from the browser and return render updates with the things that change. So, I invite you to add the next feature. The code of the talk is in that repo, so feel free to take a look at it. Don't hesitate to talk to us outside, and thank you so much.